Hey guys, welcome back to my YouTube channel, and today we'll be presenting tutorial 4 Docker Compose Spring Boot and Postgres, building REST PIs in Spring Boot and CRUD operations with Postgres SQL. So what we'll cover in this tutorial is REST controllers and bases, CRUD operations endpoints using Spring Data JPA, and repository handling HTTP response and understanding the controller. So I'm in my tutorial controller right now. What we see is an at-rest controller. Let me just show you. We have an at-rest controller, and it has a base path API, and it uses tutorial repositories for data operations. Then it enables the front end access using the add cross origin. As you can see here, we have the add x or cross origin, right? And we can also get the all tutorials endpoint, which comes here. We're using the fetch all method that supports searching by title and returns the 200 status with the data and the true for no content if empty. We can also get the tutorial by the ID, and it looks up the tutorial using an ID, and it creates the tutorial and accepts the JSON request body and creates a new tutorial with the title, the description, and the publish. Now, to show you on the front end what we get is this. I'm using an app called Hopscotch. Hopscotch is like my Postman. It's just that my Postman is not working now. So we have the title, we have the description, and published false, right? And then we have the put API tutorials ID. I just want to show you on my localhost 8080 we have this, and just to show you all the tutorials, I'll just do this and reload. No, let's just cancel this one. Now we have all the tutorials, we have Docker and all of that. We have 11 tutorials. Now let's continue. Now we're going to go to our introduction to model layer. As you can see, I have tutorial inside here. And what is happening? What is happening? It represents a data structure stored in the database using a JPA. A JPA stands for Java Persistence API. It maps the Java objects and data tables, and as you can see, I have add intentity. Intentity marks this class as a JPA intentity mapped to a database table. And then I have add table. It maps to the tutorials table in Postgres SQL. And then I have my primary key with the auto generated value. And then I have my key features annotated with add entity connected to the table tutorials and contain the fields ID, title, description, and public, right? And as we go on, we have our add column. Our add column, it is specifically for our column title tutorial, and we have our column for the tutorial description, and we have our column for the published status, whether true or false, it doesn't matter. And then we have the default constructor required by the JPA, right? And then after we move to our tutorial repository, as you can see here, I have it. Now what is happening in here? We are understanding the repository layer first. What is the repository? It handles the communication between the app and the database. So it uses the Spring Data JPA, and it eliminates the boilerplate SQL and provides a built-in CRUD operation. Now, as you can see, we have what we call our public interface tutorial repository. Now, in this, it extends the JPA repository and automatically inherits the .save method and the find by ID method and the find by all method and the delete by ID method and the delete all method. All these are generated by Spring automatically. Then I have my list tutorial method. What is happening in here? It retrieves all the tutorials where they are published, whether true or false, and it is used in the endpoint, and Spring automatically converts this method name into an SQL query, right? Then we go to our main application before we can demo what is happening in our SQL and our Docker. So we have our main application here. This project start from one main class, right? And the purpose of this class is the entry point for the entire Spring Boot application. Automatically started and embedded Tomcat server and the Spring context and the component scanning and auto configuration and no XML configuration needed. Now we want to understand this application more. So there are annotations used here. So this annotation combines three important features, which is what? Configuration, and it marks the class as a Spring configuration. And then number two, we have enable auto configuration. It lets the Spring Boot auto configure beans, and then it detects the JPA. And then we have our PostgreSQL web add component scan annotation. It scans the packages for controllers and repositories and models and services. So the final product, how this app works. When we run the main application, Spring Boot initializes the application and loads all the beans, which is the controller, the repositories, the entities, and connects to the PostgreSQL database and starts Tomcat on a default web browser localhost 8080. Now my API becomes available at the endpoint, and then I have API tutorials, right? Now we're going to go to our application properties inside our resources. Now what is happening here? Our application configuration overview. The file configures a database connection and PostgreSQL credentials and JPA Hibernate behavior and SQL formatting for debugging. This file tells Spring Boot how to connect and manage the database. So it connects to a local PostgreSQL instance. Then as you can see, we have the URL for our database for PostgreSQL and the local host, the port that we're running on, and the password. All of that is set in our PG admin 4. Now let's continue. We have our Hibernate DDL auto update. Now we want to know what is DDL auto update. Now it automatically creates and updates the database tables. We don't need to manually run the SQL scripts. And then we have our PostgreSQL dialect. Now it ensures SQL matches the PostgreSQL syntax. Then we have our show SQL true. Now this just prints the SQL queries in the console. And then we have our format SQL. What is happening in here? It makes the SQL easy to read, and it is helpful for debugging and understanding the database interactions. Now why does this whole configuration matter? This whole configuration matter because it ensures our app can reliably talk to our PostgreSQL and automatically migrate tables. It helps the developers to see how JPA SQL generates SQL, and then the Docker compose YML. We go into the final file, and then we're going to demo our product. Now what is happening in our Docker compose YML? This project uses Docker compose to run PostgreSQL without installing it manually. It is an easy setup, and it is consistent environment and automatically database startup, the data persistence through the volumes. So now what I did is I ran this following command to install and update my Docker because it was outdated. So this is the output that I got before my product started. After that, I invoked my REST method and went to my Docker. Just wait a minute. We go into our Docker. As you can see, I'm running on port 5432, which comes from my application YML, meaning that everything is running well and it is connected to our Docker dexport. Now we can go to our PG admin. In our PG admin, we have our tutorials and we have the table. As you can see, I selected from our public tutorials, order by ascending order. We have all our tutorials, the ID, the description, and published and title. Now, how did I do this? I worked in my Docker YML and my application properties. Remember that in our application properties, we telling Spring to connect to certain port and what is the password and how it must run. So my application properties work together with my Docker Compose YML. So that is how I started my Docker, and after that I went to my, let's just go here to my PowerShell. Now to add more what is this? To add more tutorials, I had to work on my PowerShell and invoked the REST method using UI HTTP localhost 8080 API tutorials, and then we post our method. This is the same as we work in Postman. It's just that my Postman is not working properly, so I'm using hotspot and the command prompt. So this is the output that we get for our tutorials, meaning that it went successfully and it is green, it is good to go. So we're working on our hotspot on our intel.js, and that is our product. Am I missing anything? Let me see. I explained everything. Yeah, that is tutorial 4. Let me see if I'm missing anything. We ran our product, we have our terminal, everything is running well. I have my resources, I have my Maven wrapper downloader, and I had to reload because I updated my pox.xml. I forgot to tell you about that. So I have my dependencies and my plugins. As usual, we have to have our Spring Boot Maven plugin, and we have to have our boot starter test. And for our H2 console, if we struggle connecting to our PG admin PostgreSQL, we can go to our H2 database and test that out. And then I did the runtime for my PostgreSQL. It will use we use it in Spring tutorial 4. We just used it now. Then I'm implementing my version, which is version 17 for my Spring Boot, and that is it, guys. That is totally it. That is it for my Spring Boot JPA PostgreSQL master. That is how I composed Docker with Spring Boot and PostgreSQL. Thank you for viewing my YouTube channel, and I hope you click that subscribe button to view more of my dope content.